Hi everyone, I am Dr. Kiran Raavi, working as an assistant professor in the Department of Electronics and Communication Engineering, MLR Institute of Technology, Hyderabad, India. Today, I cover BJT configuration, common collector configuration. So let us see overview of today's presentation. So we start with introduction and different configurations of the BJT, and particularly we will mainly focus on analysis of common collector configuration, CC configuration, and after that we'll study comparison of common base, common emitter and common collector and conclude with summary. So let us start with introduction. So what is BJT? What is transistor? Transistor is a transfer resistor because the signals are transferred from low frequency region to high frequency region. It is a 3-terminal device and it has 3 terminals. The three terminals are emitter, base and collector, and it is a 3-terminal device and 2 PN junctions. So emitter base junction and collector base junctions. So this is emitter base junction and collector base junction. And then mainly why bipolar transistor is so called bipolar, because its operation depends on both electrons and holes, that is minority and majority charge carriers. And there are 2 types of transistors, BJT transistors. Those are NPN transistor and PNP transistor, and figure shows NPN transistor and this is PNP transistor. And how to recognize NPN transistor means, so this arrow indicates current flowing out of the transistor, so hence we can say it is NPN transistor, and this is PNP transistor because current entering into the transistor. From this we can say it is a PNP transistor. This is NPN and this is PNP. So after having knowledge of this transistor, NPN transistor, PNP transistor, so let us start the configuration. So depending upon the 3 terminals, so because transistor has 3 terminals, so it can be configured in 3 different ways. So those are common base, common collector and common emitter. Okay, so today we mainly focus on common collector configuration, as we have already discussed common base and common emitter in my previous videos. So let us see what is common base, common emitter and common collector. So common emitter means emitter is grounded here, hence it is called common emitter configuration. This is common base, this is CE and this is CB because emitter terminal is grounded, and here it is CC. Common collector is grounded here, so therefore we can say it is common collector. So we have common emitter, common base and common collector. Okay, so we mainly focus on common collector, analysis of common collector configuration. So let us see one by one. So common collector configuration. So let us see the description. The collector terminal is connected to the ground, also called emitter follower. So common collector can also be called as emitter follower because output follows input. So or we can say output voltage follows input voltage. So it is also called a voltage follower. It is also called as voltage follower. Hence we can say emitter follower or voltage follower. Here the input is applied between base and collector junction. So here, input is connected between base and collector, and output is taken across emitter and collector. So this is input side and this is output side. Okay, and then the emitter base junction is forward bias and collector base junction is reverse bias. This is because this is collector here, base and collector. So this is base collector junction we have, and here you have emitter collector junction. So 2 junctions are there. So input junction is base collector junction and output junction is EC, that is emitter collector, because collector is common. So BC and EC, base collector junction and emitter collector junction. So these are the 2 junctions. So this junction will be forward bias and this junction will be reverse bias. That means input terminal is base terminal and output terminal is emitter terminal. So what are the key features? So let us see key features of common collector. Its voltage gain is approximately 1 only. So less voltage gain, current is greater than 1 current gain. Impedance matching. So the important property of common collector configuration is it has a high input impedance. So hence this kind of configuration can be utilized in the circuits where high input impedance is needed. And then advantages of common collector configuration. So usually it is used for driving low impedance loads. And another advantage is no phase shift. So output, in between output and input there is no phase shift. So usually if you consider CE amplifier, so there is a 180 degrees phase shift between input and output. So there is no phase shift for common collector configuration, and this is very good for buffering. So it can be used as buffering circuit. So these are the applications of common collector configuration. Circuit diagram. So this is the circuit diagram for common collector. Here collector this is N, P, N transistor. So this is collector terminal is grounded here, and we apply across base collector input, and we will take output across emitter and collector. So these are the output voltage VEC and this is the input voltage VBC. So let us write input parameters and output parameters. So input parameters are what? So input parameters are, because IB and VBC. Why VBC? Because base terminal is at top polarity. So hence VBC. So input characteristics means it is the graph drawn between VBC and IB for fixed values of VEC. So here VEC. So emitter terminal is top polarity. So therefore we can say input characteristics means it is the graph drawn between input voltage, that is VBC, and input current IB for fixed values of output voltage VEC. So here VEC kept constant and the VBC is increased in equal steps and the corresponding base current IB is noted. So here IB is noted here because input side. So input side is getting, we have applied forward bias input side and output side reverse bias, because if you observe, this is P type, N type semiconducting material and this is connected to the negative positive of the battery. So we can say output section is reverse bias and input section is forward bias. So therefore when we increase VBC for, let us say when VEC is equal to 2 volts, when VEC is equal to 2 volts and we are increasing the VBC, so input voltage. So in such case there is no current, IB current increases because output section IC is decreases. So when VBC increases, your IB current decreases because there is a change in the depletion width and IB also decreases. So hence you get this steep like this curve. Similarly, if you increase VEC, so VEC increases next. So what happens? And you correspondingly you need to increase VBC because IC will be reduced. IB will be reduced further if you increase VEC output voltage, that is reverse bias voltage. So therefore we have to increase some VBC, that is input voltage, in order to get the previous value of IB. So hence the curve look like this. So the steep is because of IB decreases and also VBC also decreases. So next, collector configuration, common collector configuration, output characteristics. So in this output characteristics, if you see what are the output parameters we have. So from the circuit diagram, What are the output parameters? We have IE is the one of the output parameters, and VEC is the another output parameter. So output characteristics means it is a graph drawn between output parameters IC and VEC, IE and VEC. IE on y-axis, VEC on x-axis. So this is output characteristics. So if you compare these characteristics with the common emitter configuration, so in common emitter configuration, so you will have some steep like this. So there is a slope across this. So whereas here it is approximately parallel to the x-axis. So initially almost same as in case of common emitter configuration. So here what happens if input VEC, the output voltage, that means for different values of IB, that is input current. So input current IB equals to 0 microamperes. In such case, same what happened, the current IB is 0 means there is no current ideally, but there is a current due to that is reverse saturation current, and that is very minute, and we can say this part is cutoff region. In this region, your BJT used as off switch, act as an off switch. Okay, and that means if you observe here, so there is no increment or no need to apply VEC for very small amount of VEC. For low values of VEC, there is a drastic increase in the current. So this area can be termed as saturation region. So in this case, there is a linear relation, or we can say non-linear, because no need to increase the VEC, that is output voltage. For if you further increase, so lower values of VEC only the current rises from the circuit. So if you further increase, only when you increase the input voltage, that is IB, so correspondingly your IC also slightly increase, but it is constant continuously. So see here, this is constant current, that is it reaches the emitter current reaches almost a saturation level. So if keep on increasing the VEC, output voltage VEC, there is no increase in the output current, because output section is reverse bias. Only base current will flow through the output side. So that is the main motto of transistor. So the signals are transferred from low resistance region to high resistance region. So that is the main cause for these characteristics. So this is about the output characteristics of common collector configuration. So let us see what are the different transistor parameters of your So let us see what are the comparisons between common base, common emitter and common collector. So a comparison of common base, common emitter and common collector configuration. So if you see the input resistance, the property of input resistance, so common base, it is low, about 100 ohms only. Common emitter, it is moderate, about 750 ohms, but whereas common collector is about 750 kilo ohm. This is very important property of common collector. High input impedance. Similarly, output resistance, it is for common base about 450 kilo ohms and moderate for CE and low for 25 ohms. So high input impedance means what? High input impedance means less current flow through the circuit. So low resistance means output resistance is low, means more current will flow. So more current will flow and it can drive many number of devices. So therefore current gain, next property is current gain. For common base it is 1, for common emitter it is high, and common collector it is high. So only for common base, so common base drawback, disadvantage of common base is current gain. It cannot give much current because alpha is equals to IC by IE. output current IC by IE. Okay, so we can say IC is approximately equal to IE. So in such case, maximum value alpha is 1 only. Hence we can say current gain is 1. And for common emitter configuration, the current gain. So current gain for this is beta. Current gain beta is equals to IC by IB. So this is very, very important expression. Okay. So IC is more and compared to IB. IB is of the order of microamperes and IC is milliampere. So IC will be more and IB will be less. So therefore, because of this reason, beta is up to approximately 400 like that. And then current gain for CC also same. So gamma is output current. What is output current here? IE by IB. Similar to this. So here IC equals to IE approximately. So same. So gamma also of the order of 200 or 300 like that. Okay. So therefore, that is the next property is voltage gain. Voltage gain of common base is about 150 and common emitter it is about 500 and common collector it is less than 1. So this is another disadvantage with the common collector. So voltage gain for common base and common emitter is good, and whereas this one is less than 1. And the next one is phase difference or phase shift between input and output voltages. So for common base configuration, the phase shift between input and output is 360 degrees. So the phase difference between input and output are 0 degrees or 360 degrees, and this is 180 degrees. Common emitter, so the phase shift, this is common base, whereas common emitter it is 180 degrees out of phase. This is 180 degrees. Okay, and then there is another property, that is for common collector configuration, the phase shift is again 0 degrees, or you can say no shift, no phase shift. Here also for common base, no shift. So only for CE amplifier there is a phase shift between input and output. Next, applications of other comparison applications are CB for used for high frequency circuits, and CE used for audio frequency circuits, and particularly common collector configuration is utilized for impedance matching. So particularly radio receivers. So in radio receivers, so we maintain some impedance matching, because the signals, whatever signals we have transmitted to receiver, so it has different impedance. So the receiver circuit has to maintain particular impedance. So then only impedance must match with the incoming signal, so received signal. So we require to maintain proper impedance matching. So this, in those cases, that means RF receivers, we required this kind of common collector configuration can be utilized. So that's all for today. So let us conclude for today's session. So today we have discussed starting from BJT configurations, common base configuration, common emitter configuration, common collector configuration, and we have mainly focused on analysis of CC and the parameters, input output characteristics, and then we have compared CB, CE and CC for different parameters. Now the next topic will be probably amplification factors. So what are the relation among alpha, beta and gamma, and if time permits, let us do few problems on these parameters. Thank you.